Tsaka starting presentation. Let me just share. Um, so, di ba, one thing that I posted on your, share with your class that we're supposed to have a photo contest on the 18th. I already included, wala naman nag-entry sa inyo, pero para may opportunity kayo na magkaroon pa rin ng points with this activity. So, what I did is I shared the link with you guys to take the survey. Okay, so, let me just go to your page here. Mm-hmm. Good, na gano'n siya. Wait lang. Edit section. Kaya pala lahat na edit. Nakopya sa inyo guys. Wait lang ha. Okay. So, I included the link for the photo contest. Oops. Okay. So, I hope you would be able to join this contest. This is equivalent to 10 points activity. It's going to be part of your midterm grade as well. So, please choose among your best picture that would be best to represent our classes or under my classes. Okay. Ayan. So, deadline po na submission ng inyong votes po would be until Thursday. So, but the earlier the better please para at least makapag-consolidate po tapos makapag-forward po na agad sa kanila. So, if you choosing your options here, then you can actually vote 3 items only or 3 pictures. Yan. And then the top scores will be the one, or the one with the higher scores will be the one to be included in the raffle or in the competition. Now, in you're answering this, make sure to click on subscribe to the parang sa YouTube. Wait lang agad. Ito po kasi itsura niya sa inyo eh. Tagal ng TBL ngayon dahil hapon na. Okay. So once you submit your votes here, magno-note po kayo dito, add a comment, susulat niyo po completed, then, okay, so, muna natin baguhin pa yung ano. So once you have already placed here completed or done, i-click niyo po to. So dalawang beses po kayo magsasubmit dito, isang submission dito, and the other one here, at the bottom of the Google form, embedded. Para papasok po sa inyo yan. Okay? Kasi otherwise, hindi po siya papasok. So far, meron ng 3 nag-submit sa inyo. Okay? So, yan. Yan. Okay, so Mayo, Rivera. So, may mga bumoto na po. Okay? So, yan po. Any questions so far, guys? Wala naman.
Ma'am, ma'am,
Yeah.
paano yung bumoto po, ma'am, na walang comment po, ma'am?
So, pero nag-submit ka dito? Or hindi?
Opo, ma'am, nag-submit na po kami.
Last
Pero
name.
may duplicate na po, mas kalimag po, ma'am.
Ano siya pumasok?
May duplicate po sa Gmail ko nag-send, ma'am.
Okay. Sige, sige, double check ko na lang siya. But can you just, ah, click sa, please repeat mo na lang to kung meron na siya.
Ayaw po, ma'am, eh. Tinry ko na rin po, ma'am.
Ano ginagamit mo? Gmail? Yung Maka email?
Opo, ma'am.
Sige, double check ko na lang doon sa actual raw scores or raw output doon sa Google Forms.
Po, ma'am.
Okay? Anything else? Okay. So, by the way, today is the last week for our discussion for this month or for the midterm. Kasi po, next week is already the midterm exam. So, from Monday to Friday, we will not be having any synchronous classes. For my class, rather. Hindi po tayo mag-meet sa Monday. So, ito na po yung last day natin for the midterms. The exam will be available from um, 1 o'clock ng umaga or pagpasok ng 12:00 ng Monday, and it will close until 11:59 p.m. ng 22nd po. Okay? So, close na po yan. Now, the coverage of your exam will be from the beginning of our discussion. So, this is actually gonna be derived from all your quizzes and quizzes na na-take na natin. Okay? So, summative test siya. So, dun ko po kukunin lahat ng exams ninyo. Okay? So, yan. So, yung mga quiz dito, yan, dito. Then, ethics here, yan, digital ethics. And then, the last discussion for today is IT in the field of biology. Yung IT concerns, gagawin na lang natin to afterwards na natin. Okay? Pero I've already uploaded the PDF for this one. Okay, baka magtataka kayo bakit 4.3 po siya kasi usually this is the fourth part nung dating MST na ginagamit. Yung lahat may pahapyaw ng bawat isang concept. Okay? So since natapos na tayo dun sa MST Living in the IT Era, we will include now a new set of topics already. Okay? So yan po. Okay, so let me just start with my lecture. Present lang ako ha. Okay. Okay. So when you talk about the future or the one that we're currently in, you might be thinking about the developments that were applied. So the information era has actually brought a lot of technical ages since 1990s. And that is not only limited through the field of IT, commerce, communication, but also with the field of science as well. So here are some of the technologies that were applied into science. So, unang-una po is digital imaging. Okay? So, medical imaging actually played an important role in terms of improving the health of the people. Okay? So, when we say medical imaging, it refers to processing of creating visual representation of the interior of a body of for clinical analysis and medical intervention in order to reveal the internal structures hidden by the skin, the bones, as well to diagnose and treat diseases. Okay. So right now the technology that we have and we'll be discussing is from X-rays until MRI and then also the other latest technological advancements that we have today. Okay? So unahin muna natin yung una-una we have X-ray. So X-ray or bone X-ray is known as radiography. Okay, so this is actually a painless medical test that helps physicians to diagnose and treat medical conditions. Now, it involves exposing the part of the body to a small dose of ionizing radiation to produce pictures inside the body. So, this is actually the oldest and most frequently used form of medical imaging. So, here you study about the bones in all parts of the body and how it may be oriented. So, yung mga may scoliosis, check ito, tapos kung may bali yung buto, dito rin natin malalaman yung extent ng damage ng pagkabali. Okay? Now, let's have a little bit background of X-ray. So, it's actually Wilhelm Röntgen who made a discovery while experimenting with electron beams in a gas discharge tube. Now, Röntgen noticed that a fluorescent screen in his lab started to glow when the electron beam is turned on. Now, usually with this a lot of discoveries, X-ray technology was invented completely by accident. Okay, so that was in 1895. Okay, now although the response itself was a little bit surprising for others, fluorescent material normally glows in reaction with electromagnetic radiation. But yung version ni Roentgen was surrounded by a heavy black cardboard, and Roentgen assumed that it would be blocked most by the radiation. Now, how did it actually did it? Okay, so this is how he placed it. So he placed various objects between the tube and the screen, and the screen still glowed. Now, finally, he put his hand in front of the tube, and he was able to see a silhouette of the bones projected onto the fluorescent screen. Okay, so ganun po nakita. And immediately after discovering X-rays himself, he discovered their beneficial application. So his remarkable discovery precipitated in the most important medical advancement of human history, which is the X-ray technology. Now, this allowed the doctors to look into human tissue, examine broken bones and cavities, and modified X-ray procedures can be used to examine softer tissues such as lungs, blood vessels, and intestines. Di ba pag nag-a-apply tayo um, sa school noon, hinihingan pa tayo ng chest x-ray. Kasi po, makita doon, pag healthy ka, ang term nila doon is clear ang lungs. Okay? So, yun po. Kasi pag clear po, ibig sabihin wala pong mga abnormal growth, tapos wala pong usually mga plema na nasa lungs yan. Or hindi masyadong makapal yung plema. Kasi pag makapal ang plema, nagiging cloudy siya. Now, in the picture here, you actually see here, ito yung mismong kamay ni Ro and Jen. May sing-sing siya dito nun eh. Okay? So, may sing-sing siya at tapos nakikita niya yung mismong kamay niya. Kaya yon. But although later on, they were able to see a lot of facts, information about the bones, then later on, syempre, nakita rin nila na marami pong negative impact din ang X-ray. Kaya nga po, as much as possible, they try to limit the amount of X-ray that will be used by women, children, and also yung mga pregnant women as well. Kasi po, it can have an adverse effect on the cells. Okay? Kaya minsan may ano lang twice a year ang pwede mag-X-ray. Okay. So here, now what is the difference between the normal X-ray and the digital X-ray? So, ang kinagandaan po ng X-ray natin ngayon, lalo na kung sa medyo social kayo, medyo magkamahalan yung digital X-ray, is that it's actually more like a camera today, which in it can easily process it faster. Okay, dati kasi since ilalagay nila sa film yan, photographic film, process nila yon, tapos makita nila agad yung result. Yun nga lang, parang picture na siya, yun lang. But with this time, it's gonna be input or placed inside a computer screen na. Okay, so it's already digitalized, which allows faster reading. So, hindi mo na kailangan pang dalhin yung x-ray film mo. Usually, sa mga malalaking hospitals, when they do medical tests right now, like for the case of St. Luke's, Makati Med, o kaya yung mga mamahaling mga clinical systems. Okay? So, pag pinasok na nila yon, majority sa kanila naka-digital na yung x-ray nila. So, pag na-take na nila yung x-ray, i-feed na kagad nila sa computer, then yung attending doctor mo will check it on a computer terminal near his area. Okay, so hindi na po padadala pa ng internist o kaya ng nurse assistant yung film mo from the x-ray room towards sa kung saan room ka naka-confine. Pwede na nila i-retrieve right away yan. Okay, so yan. So that is the difference with them. And at the same time, being a digital, it will actually make it clearer and more accurate pictures kasi nga ipapasok na sa computerized system yan. Ayan, and as you can see here, yung x-ray ng patient nakalagay sa isang iPad. Okay? So yan, handy na siya. Hindi na kailangan ng um, actually mas madali din sila ngayon kasi pag nilagay nila, naka-print out na rin sa computer. Kumbaga, nililabel na mismo ng computer din. Pag nung experience ko nagpa-medical ng one time sa St. Luke's because of an emergency, nung may medical card pa ako. As in, yung mismong film, computer magle-label, tapos ikakabit mo na lang doon sa ibabaw nung plate. Tapos, sabi sa akin, nung tinanong ko sila how it works, usually yung newer version, ano na siya, yung x-ray film, nare-reuse na nila. Hindi katulad dati na once na natanggal mo na yon, pag nakuha mo na yung itim na film na yon, yun na. Ito pwede siyang i-reuse pa. Okay? Now, so that's the first imaging device. Now, the second one is fluoroscopy. So this is a type of medical imaging that shows continuous X-ray image on a monitor. Parang X-ray movie siya. Now, during fluoroscopy, procedure, an X-ray beam is passed through the body. The image is transmitted onto a monitor so that the movement of the part instrument can contrast and can be seen via an instrument or using a contrast agent. Now, usually the contrast agent can be an X-ray dye or radioactive material that can be seen in detail. So, here is an example of fluoroscopy. So, may iniinom siya. Yon. So, uminom siya ngayon ng radioactive iodine. Okay. So, makikita nila ngayon kung maganda yung ah, muscles, yung mga bones. Yan. Okay, so the benefits of fluoroscopy is ito po yung mga marami po, very wide yung use niya. Then they use different applications or different materials to help in viewing. So you use barium and enemas to check the gastrointestinal tract. Then catheter insertion and a manipulation to direct the movement of a catheter through the blood vessel, bile ducts, and urinary system. Placement of devices within the body such as stents. So usually itong stents po nilalagay ito sa mga blood vessels na na-block na. And then angiograms to visualize blood vessels and organs. And orthopedic surgery for guided placement and treatment of fractures. Okay? So yan po. So yung mga nag-opera ng buto, tinitingnan nila baka mali yung pagkaka-align nila ng buto. Okay, so that is for fluoroscopy. Now here is angiogram. So it's almost similar, it's similar to fluoroscopy, kaya lang ano yung pinafocus niya. Yun ang naman kasi ang difference sa mga yan eh. So for angiogram, you're actually looking at blood vessels. So here's an example of a blood vessel inside the lungs. Okay? Kaya siya lungs kasi po ito yung kanyang rib cage. Yan, tinitingnan yung flow ng blood niya. Okay? So, it's a X-ray that uses pictures of your blood vessels. Ayan, mapapansin niyo meron siyang tumatapon na blood vessel dito. Okay? Pag humihinga. Ayan, parang may umuubo na blood. So, ibig sabihin, merong punit po siya dyan. Okay? So, usually, a long flexible catheter is inserted through the bloodstream to deliver the dye. Yun yung nakikita natin na nasa loob. To stream into the arteries, making them visible on the X-ray. The test can help diagnose a stroke, aneurysm, arteriovenous malformation, tumors, clots, and arterial stenosis. Okay, so yan po. So mapapansin niyo, nung nag-pass through ng dyes, yung ibang mga blood vessels hindi niya na po nadaanan. Kasi nga po, meron siyang butas dyan. Okay? So the angiogram is similar to an X-ray. The body casts a shadow on the film when it's exposed to X-ray, such as when you hold a flashlight on your hand and cast a shadow on the wall. Not normally your blood vessels cannot be seen in an X-ray, but adding a dye or the construct agent, the blood streams can make it visible in the arteries and veins. So as you can see here. Okay. Now take note that it contains iodine, a substance that wherein nakikita yan ng X-ray. Okay, so yan po yung nangyayari dyan. So usually pag merong namuo dyan or merong nag-start to, nag-stop doon yung blood flow, ibig sabihin, ando doon yung blood clot. So parang dito may parang blood clot yata siya, if I'm not mistaken. Okay, but by the way, I'm not the doctor yet. Not a medical doctor. You know, parang may blood clot dito siya. Okay, next. Now, what do you need to remember when you're doing um, an angiogram? So, usually when you deliver the contrast agent, a catheter is advanced from the femoral artery. So, yun sa pita yan. So, din po yun kasi yung pinakamatabang artery. Okay? So, into the leg of the four arteries and to the neck that lead to the brain. So the doctor steers the catheter through the blood vessels while watching a monitor, a fluoroscope machine called the CR. Ito po yung C-arm. Okay? Yan po yun. That generates X-rays from one side and photographs then on the other. So ito po yung kabila na nagsisend ng ito po yung nagsisend ng X-ray, if I'm not mistaken. And then yung isa po yung nag-take ng results. Okay? Yeah. So contrast is injected in the bloodstream to make the blood vessels visible on the monitor, and the result is a kind of roadmap of arteries. Okay, so yeah. Next is mammography. Okay, so mammography naman po is an X-ray image of your breast. Okay, meron din pong panglalaki na mammography, hindi lang po babae ang may mammography. Okay? So, yeah. Now, it can be used for screening breast cancer or other diagnostic purposes. Okay? Paano po yung ginagawa? So, if you can see here, merong film. Ito po yung pang x-ray. Ito po yung film. Okay? So, in mammography, they help the doctors examine and diagnose the patient by exposing the breast into small X-ray or ionizing radiation to produce the picture inside the breast. Okay? Now, in terms of advancements in mammography, guys, medyo ano to masakit. Experience ko na magpa-mammography, guys. Yung breast mo, ilalagay mo dun sa flat na yon. Okay, here, let me just go back to the previous slide. Yan, ilalagay mo dyan as shown here. Okay? Ano to? Picture lang to, hindi to actual na example. Computer generated siya. So, ilalagay mo dyan yung boobs mo. Then, ito po, may pressure yan. Ipipipi yan hanggang sa pinakamapiping kaya niyang ipipi yung boobs mo. Okay? So, masakit yan. Yan sabi ko sa inyo, talagang mangiyak-iyak ako nun. Parang alam mo yun, parang pipipiin, halos manipis na. Nipisin yung dead niyo dyan. Okay? Then, pag manipis na siya, saka ka lang gagamitan ng x-ray. Okay? So, as tagatapos mo dito, yung kabila naman ay papatong mo dyan. Okay? Parang lalo kung malaking boobs mo, parang papatong ka ng ano dyan, hita dyan. Okay? Pero boobs yung nilalagay nyo dyan. Then, ganun ulit. Ipe-press siya hanggang sa pinakakaya niyang manipis. Okay? Hanggang sa kayang-kaya niya na i-press yung boobs niyo, tapos saka siya i-x-ray. Okay? So, yeah. Now, in advancement of mammography, unang-una po, of course, digitalizing it. So, digital mammography is a system wherein ginapalitan na yung films in by electronics that convert x-rays to mammographic pictures of the breast. Okay? So, hindi na po siya by film doon. At talagang bibigyan kayo guys ng isang ano, parang x-ray film na maliit. Yun lang ang laman niya is yung x-ray ng dede na. Okay? So these systems are similar to other digital cameras, and their efficiency usually enables better pictures with lower radiation doses. And the images of the breast are transferred to the computer for review by the radiologist and for long-term storage. So the patient's experience during a digital mammogram is similar to having conventional film mammograms. Okay. Next is computer aided detection. So using computer aided detection system, it actually searches the any abnormal areas for density. So when you say mas makapal na area, yan, makita mo may mga bilog-bilog. Okay, may mass or calcification that may indicate the presence of cancer. Okay, so CAD system highlight these areas in the images, alerting the technologist or the radiologist to carefully assess this area. Okay, and next is breast tomosynthesis. Okay, so this is called the three-dimensional mammography digital breast tomosynthesis or DBT. Okay, so it's an advanced form of breast imaging where multiple images of the breast from different angles are captured, reconstructed, synthesized into a three-dimensional image. Okay, parang ano to, similar to uh, sa MRI, pero po, ang kinaibahan nila, yung sa MRI kasi yung 3D pictures na mapoproduce sa MRI is gamit magnetic field. Ito po, gagamit ka ng X-ray. Okay? So, yeah. So, next one is computer or computed tomography or CT or CT scan. Okay? So, it refers to computerized X-ray imaging produced in which a narrow beam of X-ray is aimed at the body and completely rotated around the body, producing signals that processes the machine's computer to generate cross-sectional images or slices of the body. Okay? Kumbaga, para in X-ray ka, from top to bottom yan, guys. Okay? From mula ulo hanggang pa. Kaya mapapansin nyo to, so ito po yung X-ray machine niya, pinapahiga yung patient. Okay? So you can actually see layers of the body showing. So ito po yung itsura niya. Yan. So here po yung layers from top to bottom. And then here you will see the different layers of organs inside. Yan. So you have the liver, muscles, the bones. Although gift po yung ginawa ko dito para lang makita nyo how it's gonna show up. Oh, but take note, this is still using X-ray. Hindi pa siya magnetic field. Okay? So yan. Ito po yung slicing niya. Okay? So they're actually going to allow X-ray extra light or rays to pass through. Okay. Yeah. So they will making successive slices are collected by the machine's computer, and then they are digitally stacked from one to form a three-dimensional image of the patient that allows for easier identification and location of basic structures such as possible tumors or abnormalities. Okay. So this is how the CT scan works. Wait lang. Palitan ko lang yung sharing niyo kasi hindi nyo maririnig yung audio. Wait lang guys. Wait lang ako. Para makita niyo kasi hindi niyo siya maririnig.
A CT scan is an X-ray procedure that creates cross-sectional images with the help of computer processing. CT images are more detailed than conventional X-ray images and can reveal bones as well as soft tissue and organs. A conventional X-ray uses a fixed tube that sends X-rays in only one direction, while a CT scanner uses a motorized X-ray source that shoots narrow beams of X-rays as it rotates around the patient. There are special digital X-ray detectors located directly opposite the X-ray source. As the X-ray passes through the patient, they are picked up by the detectors and transmitted to a computer. Image slices can either be displayed individually in two-dimensional form or stacked together to generate a three-dimensional image that can reveal abnormal structures or help the physician plan and monitor treatments.
Okay, that is for CT scan. Okay, let me just go back. Okay, so the next one is ultrasound. Okay, so ultrasound is an imaging test that used sound waves to create a picture, or also known as sonogram, of organs, tissues, and other structures inside the body. Now, the difference with this one compared to x-rays is that it does not use x-rays. Okay? It only uses sound waves. So the ultrasound can show parts of the body in motion, such as heart beating or blood flowing from through the blood vessels. Now, it's usually divided into two types. You have the pregnancy and diagnostic ultrasound. So when you see pregnancy ultrasound, it's actually used for pregnancy. So confirm kung pregnant ka, to check the size and position of the unborn baby, to check if you're pregnant with more than one baby, and how long it's gonna be how long is the pregnancy is. So usually sinasabi niya na kahit na 4 months ka, but based on the size of the baby, based on the ultrasound, sabihin kasi ng ultrasound kung ano kung gaano kalaki lang yung baby nyo. So sabihin niya, your baby is actually 3.5 months lang. Pero alam mo nung nagbilang ka, it's supposed to be 4 months. So ibig sabihin that there's something wrong with the development of the baby. Baka hindi ka masyado kumakain. Then it's also used to check for Down syndrome, okay? Which will be including showing the thickening in the back of the baby's neck, okay? And then birth defects in the brain, the spinal cord, the heart, and other parts of the body, okay? And also the amount in the amniotic fluid. Now, the other one for diagnostic, marami po yan. So, una-una, kung meron bang flow ng blood, how fast it is flowing, and the level. And then, if there is a problem with the structure of your heart, baka naman ito, tumatama siya dyan, like the one that you have here. Although this is for the lungs, okay? Blockages in gallbladder, thyroid gland cancer, or non-cancerous growths. Then you have also abnormalities in the abdomen and kidneys. Huwag masakit yung likod ninyo. Then biopsy procedure, yun yung ginagamit para i-guide. Okay? Now, ano ba yung modern ngayon in terms of ultrasound? So right now, we have different types of ultrasound in terms of clarity or the type of dimension. So you have the 2D, ito yung mga nakasanayan na natin. Then you have the 3D where you can see some pictures. Parang nakikita mo yung kung ano tsura niya. Then 4D, mas klaro, mas clear yung kanyang pictures. Okay? Okay? And then, real time mo siya makikita. Okay? So, habang ginagawa yung ultrasound, you can actually see the picture, the baby inside real time. Okay? So, 4 dimension. Okay? And the next one is high dimension. Wait. Okay, when you say high, oops. Wait lang, guys. Okay, when you say definition or high def, parang TV yan. So, ganun din. It's gonna give you a more crisp image, well-defined, and then it gathers more details on the image compared to 3D and 4D. Okay? Mas maganda yung rendering. Okay? So, sabi nga nila yung HD is considered as 5D. Okay? Fifth dimension yan. Kung kumpara mo dito, hindi less ang grainy niya compared to the 4D. Okay? So that is for ultrasound. Okay? Now, the other one is MRI or magnetic resonance imaging. Okay? So it's actually using a magnetic field and computer generated radio waves to create a detailed images of the organs in your body. Okay, so here, let me just show this to you.
One
Hindi nyo kasi maririnig to pag ano eh.
out of 4. That's how many people will. One out of 4. That's how many people will die.
1 out of 4. That's how many people will die of a heart-related problem. Doctors at Mayo Clinic are trying to improve those statistics. They're using MRIs to look inside the heart to find disease and tailor treatment to keep people healthier longer.
You can breathe normal.
Magnetic resonance imaging, or MRI, allows doctors to look inside the heart as it beats.
You can see here, this is the left ventricle, which is the main pumping chamber that pushes blood out of the body.
Dr. Brian Shapiro uses MRI to look for abnormalities in the heart.
What the MRI does is it looks at the tissue characteristics of the heart. So swelling of the heart is a very common thing in heart attacks and infections and things like that.
The moving or still images show exactly where damage happens.
You would see it as a very bright spot in the heart.
In addition to damage from heart attack or infection, MRI can also show Dr. Shapiro how well the heart pumps, where irregular heartbeats originate, the location of blood clots, artery blockages, scar tissue, or even tumors. Because MRI allows doctors to see more detail of the heart, they can make more accurate diagnoses and therefore tailor treatment for patients.
Is you can actually show where the heart attack is and the extent of the heart attack.
Images that tell Dr. Shapiro if a patient will recover, if there's permanent damage, and what treatments might be best. Information from inside the heart that can help Dr. Shapiro and his colleagues better help their patients. Dr. Shapiro says while MRI can show lots of information about the heart, it does not replace other tests such as stress tests or echocardiograms. Heart-related it's another option. Doctors at Mayo Clinic are trying to improve. For Medical Edge, I'm Vivian Williams.
Okay. So the next one after MRI is your nuclear medicine. So nuclear medicine is actually a medical specialty that involves giving patient a small amount of radioactive medication called radiopharmaceutical, and then this makes the body slightly radioactive for a short time. And a special nuclear medicine camera detects the radiation which is emitted from the body and takes images of the pictures and how the inside of the body is working. Okay? Now, usually ito po yung mga nakikita when it's checking for when you're taking nuclear medicine. So, swallowed, injected directly to the tissue beneath the skin, inducted into a shunt, into a joint, at pag na-inhale mo siya. Okay? So, actually, I have another video here on regards to nuclear medicine. Wait lang ha. I'm, I'm testing on a way that would allow me to send the audio to you guys in the presentation. Wait lang ha. Change na ako ng preview. Okay, so please take note of the information that is being shared in the videos kasi po, dyan po kuha tayo ng mga questions sa exams niyo. Okay?
My name is Amber. I'm the nuclear medicine coordinator and I work mainly in the nuclear medicine department and also the PET department. Nuclear medicine is a medical specialty that involves
Take note ha, yung term na ginamit niya sa nuclear medicine, another term for nuclear medicine is PET. Okay, PET.
Somebody with a small amount of a radioactive material, often called a radiopharmaceutical. We can also give it to you in other ways, for example, by swallowing, by putting a small amount under the tissue underneath the skin, and also we can get you to breathe it in. We then use a special gamma camera that actually takes pictures of where that injection has gone to in the body. This helps the doctors determine disease states in the patient. Nuclear medicine can also be used to treat diseases. When we are treating diseases, we often give a larger amount of radioactivity, but then that is targeted to a certain disease and a certain organ that we are trying to treat. For the nuclear medicine studies, the nuclear medicine technologist will perform your study. The nuclear technologist has obtained a university degree, so they are very capable and qualified to inject the radioactive materials, prepare the radiopharmaceuticals, perform the actual imaging, operating the gamma camera, as well as displaying and processing the images that are required. A radiopharmaceutical is a special medication that is used in nuclear medicine. There is a radioactive component which helps create the image that the gamma camera will detect, and the pharmaceutical component determines where that injection will go in the body. When you are given the radioactive material, gamma rays are coming from your body, that is the radioactive component. Those gamma rays will hit the crystal within the gamma camera head, and that helps to form an image, which is then relayed onto a computer. When we give you the injection, you will not look or feel any different. You will not feel the sensation of the radiation at all, and you will not be glowing in the dark. Also, the gamma camera does not make any noise, so the whole procedure, when you go through it, is quite simple, and there's nothing to be fearful of while we're actually taking the images. So the way nuclear medicine and X-ray differ is that when someone has an X-ray, we're looking at what something looks like. With nuclear medicine, when we give the injection of the radioactive tracer, we're actually following the pathway of injury. So nuclear medicine would look at function rather than just what something looks like. Imaging of pregnant women in nuclear medicine is generally avoided, but there are some circumstances, after discussion with the referring doctors, that sometimes a nuclear medicine test could be performed on a pregnant woman. Most times this is usually when they're trying to diagnose blood clots. Patients who are breastfeeding or are in close contact with young children may need to be given specific instructions if they're having a nuclear medicine test. With the breastfeeding, we often request patients to cease breastfeeding for a certain time period. They are able to express their milk and put it away prior to their examination, and then we will let them know when they can recommence breastfeeding. If you are the primary caregiver of small children, we recommend that you talk to your doctor and also to us when you come in about the precautions that you would need to follow. We do recommend that you keep your distance from young children and pregnant women for a certain period of time at a distance of preferably 2 to 3 meters, just so that we can minimize the dose to the children. So when you come into our department to have a nuclear medicine procedure done, the technologist will walk you into the room. They will get you to take off any metal items that you may be wearing. We will get you to lie down on our table. Once you are in position, and we will position you under the gamma camera depending on the area of the body that we are scanning, we will then give you the injection of the radioactive tracer. Once we give you this injection, it is important for you to keep still because often the pictures are commenced straight away. Then, depending on what procedure you're having done, we may get you to leave and come back at a later time, either on that day or a different day. So when you're booking for a nuclear medicine procedure, often the receptionist will inform you of how long your study will take, but on the day the technologist will also remind you prior to commencing the study how long you will actually be here for the procedure. Now, with nuclear medicine, there are a lot of images that we do take. Once we have taken the images required for your study, we then need to process the images. They are then sent on to our specialist radiologist, who will interpret the images and provide a report, which then can be followed up with you and your doctor.
So that's for that. Let me just go back to the PowerPoint. Wait lang ha. Okay, so the last one is polymerase. Sorry, second to the last pala to. So this, we still have the Human Genome Project. So polymerase chain reaction is a laboratory technique that is used to amplify DNA sequences. Now, the method involves using short DNA sequences called the primers to select the portion of the genome to be amplified. Now, it is really important to follow the temperature because it will actually help raising the temperature, lowering it to help the replication process. Now, the technique can actually produce billions of copies of the targeted sequence within just within a short hours. So I have here for two videos related to the PCR. Now, remember the PCR is the one that we are using for testing COVID-19. Okay? So, inahin mo muna yung kay Amoeba Sisters. Now, please take note of the details that I'm gonna be mentioning here. Kasi po, again, nagawa ko na po yung exam. You can actually take the exam right away after this discussion. And it's gonna be a little bit detailed on the description here. Okay, so let me just change it because it's gonna be a video.
Amoy kulo! Skip the club stain. Mas pinagaling na ang Algel with 10 times cleaning enzymes.
Get salon-tastic
Wait,
smooth hair, even at
wait lang
home.
ha.
New Pantene Intensive Serum
May ad pa
Conditioner.
kasi. Okay. So, we have here the Amoeba Sisters. Maganda naman yung explanation nila with regards to issues about science and very madali silang ma-pick up. Pero tama naman yung mga details nila. Okay? So, let's go to Amoeba Sisters.
There are some pieces of technology you really develop an appreciation for. Maybe it's your phone, your laptop, your drawing tablet, but for me, it is the copy machine. Oh, the copy machine. I know it's not possible, but I could promise you that whenever the copy machine was aware of my presence, that's when it decided to malfunction. Especially if it knew I was short on time. And of course, when it jams, the fancy copy machines will even tell you what is wrong and how to fix it. But my experience with trying to follow the instructions of fixing the copy machine makes it worse. And then by that point, there's a line, and you feel your heart pounding, and you're embarrassed because now you've jammed it for everyone. Yeah, so while I've developed an appreciation and respect for the copy machine, I've definitely tried to limit my use of it over the years. Saves paper anyway. You may be wondering, why is she spending so much time on this? Well, I want to call your attention to a technology, a biotechnology, that works almost like an amazing and fancy copy machine. Except not for something on paper. No, it's for DNA. This biotechnology is PCR, polymerase chain reaction, or PCR for short. It provides a way to make more copies of a portion of DNA. Lots and lots and lots of DNA copies, and this technology does not need to happen in a cell either. In fact, it can happen in a test tube. And so you may wonder, number one, how does PCR work? And number two, why? Why make more copies of some specific portion of DNA? So let's briefly answer those two questions. To answer the first question, the how does this work question, let's talk about what we need first before we get to the steps of how it works. We need the DNA portion that we want to make copies of. We need some kind of buffer to put it in, and then we need things that would be necessary to make more copies of the DNA. So think about what that might mean from our DNA replication video. We'll need primers. Recall that primers help DNA polymerase, a building enzyme, know where to go to start its building. We need DNA polymerase, the building enzyme. Fun fact, the DNA polymerase used is often a heat-resistant type of DNA polymerase as PCR uses heat. typically, the polymerase chosen for the job is Taq polymerase, a type of heat-resistant DNA polymerase. Taq polymerase is originally from a type of bacteria that can handle and live in really high temperatures in nature, in hot springs. Pretty cool. We also need DNA nucleotides for the DNA polymerase to build with. So we can look at the PCR sequence in 3 major steps. We'll illustrate with one double-stranded DNA molecule here, and let's assume this is what we want replicated. Step 1, denaturation. You've heard that word denature before, right? When we were talking about enzymes? One way we had talked about denaturing enzymes was using heat, and heat is what we will use in this step. This step involves the addition of heat needed to separate the 2 strands of the DNA molecule. Step 2, annealing. Okay, so this word means something a little different in biology. Basically, this is when the 2 DNA strands that now have been separated by that heat are going to be cooled and be joined by the primers. The temperature for this step should allow the primers to bind to the specific segment of DNA that you want to amplify, which means make copies of. Step 3, DNA synthesis. Remember, synthesis means to make something. With DNA synthesis, we're going to make more copies of DNA. And to do so, DNA polymerase will begin to work on both of these strands, and it will use the DNA nucleotides as its building material to amplify the DNA. We should note that the temperature at this step may be a little warmer than the previous step. It needs to be a temperature that is ideal for the specific DNA polymerase used. Now, after finishing one cycle of this, you have 2 double-stranded DNA molecules, right? Similar to how it would be in DNA replication within a cell. But you can repeat this now, except this time you now have 2 double-stranded DNA molecules to start with. So you repeat with the denaturation, annealing, and DNA synthesis steps. Now you have 4 double-stranded DNA molecules. You repeat the steps again. Now you have 8. And if the process is automated by a machine, which, why yes, they do have in science catalogs, you can actually do this fairly quickly. Which brings you to why? Why do this? Well, any technology that needs copies of a portion of DNA could find PCR useful, but we'll just mention 2 examples in our limited time. We mentioned DNA fingerprinting in our gel electrophoresis video, and we mentioned that DNA fingerprinting can be part of a crime scene investigation. Well, in order to have enough copies of DNA samples to run in gel electrophoresis to analyze, PCR can be performed to make copies of the fragments of DNA that are found at a crime scene. Another example? Diagnosis of a disease, such as one caused by a virus. For an especially relevant example, I can mention one of the testing types done for the virus that causes COVID-19. COVID-19 is a pandemic that we're experiencing right now in 2020, and the virus that causes COVID-19 is called SARS-CoV-2. You might have heard of one test type that uses a sample from a nose or throat swab in a PCR test. But to be more specific, this test for this virus is a real-time reverse transcription PCR test. The reason it has this fancier reverse transcription in there is because this virus uses RNA as its genetic material instead of DNA. And you have to use an enzyme called reverse transcriptase to convert the RNA into DNA. So before we can do the regular PCR steps we've mentioned, we must convert isolated and purified RNA into DNA. A specific primer is added that will bind to an area of viral RNA, and then reverse transcriptase is used to convert viral RNA into cDNA, complementary DNA. Using specific primers and the Taq DNA polymerase, the cDNA can be copied over and over each cycle in the familiar steps we've been mentioning of PCR. See, the goal is you need enough copies of the viral cDNA in order for it to be detectable. The idea being, if it's a positive result, you have these selective primers binding, and you have the Taq DNA polymerase making more and more copies of the viral cDNA each cycle. In addition, specific fluorescent probes are also used for identification. A certain level is needed for identification of a positive result. And if the virus's genetic material is not present in the sample, then primers wouldn't bind, and there would be no cDNA copies produced. If you'd like to learn more about this test as far as its limitations and also its complexity, as we're being pretty general here.
Okay, so that is for PCR according to the amoeba sisters. Now here is the specific components for the chain itself. And,
Polymerase chain reaction, or PCR, uses repeated cycles of
and,
polymerase chain reaction.
okay, let me just share this with you here.
Polymerase chain reaction, or PCR, uses repeated cycles of heating and cooling to make many copies of a specific region of DNA. First, the temperature is raised to near boiling, causing the double-stranded DNA to separate or denature into single strands.
Take note of the temperature ha, para ano, mentioned here. So it is actually at 95 degrees wherein the DNA strands will be separating.
When the temperature is decreased, short DNA sequences known as primers bind or anneal to complementary matches on the target DNA sequence. The primers bracket the target sequence to be copied. At a slightly higher temperature, the enzyme Taq polymerase, shown here in blue, binds to the primed sequences and adds nucleotides to extend the second strand. This completes the first cycle. In subsequent cycles, the process of denaturing, annealing, and extending are repeated to make additional DNA copies. After 3 cycles, the target sequence defined by the primers begins to accumulate. After 30 cycles, as many as 1 billion copies of the target sequence are produced from a single starting molecule.
Okay. So yeah. Okay, let me just go back to the PowerPoint. Okay, so the last one now, second to the last is the particle accelerator. So a particle accelerator usually propels particle charges such as protons and electrons at high speed, close to the speed of light. So they are actually smashed either into a target or against a particular particles, okay, in opposite direction. So if you watch yung Angels and Demons, yan po yan. Yung nagsimula yung video nila when you have a cyclotron. Okay. So by studying this collision, physicists are able to probe into this world of infinitely small. And when the particles are sufficiently energetic, the phenomenon that defies the imagination happens. Energy of the collision is transformed into matter in the form of new particles. Now, the most massive of each existed in the early universe. Now, this is actually explaining the concept of Einstein's E equals mc squared, okay, wherein mass is concentrated from energy and the two are interchangeable. So energy can become matter, matter can become energy. Okay. So how does it work? So here. So there are actually two types of particle accelerator. So you have the linear and the circular. So the linear accelerator usually propels particles along a straight line, kaya nga linear siya, and on a fixed target experiments. Now, on the other hand, circular accelerators usually work on a circular track and can be used for both colliding beam and fixed target experiments. Okay, so let's get this one. Okay, let me just go back.
Check the label, mommy!
Mas todo sa nutrients to. Sulit! Todo Protect with Needle-Free Plus.
Breeze is changing with eco-clean technology to be tough on stains and kinder to the environment.
One of the grandest scientific tools ever made by mankind is called an atom smasher. And I mean literally grand. The biggest one ever built, the Large Hadron Collider, or LHC, is a ring with a circumference of about 18 miles. That's more than the entire length of Manhattan. So what is an atom smasher? It is a device that collides atomic nuclei together at extremely high energy. The most powerful one scientists have ever built can heat matter to the hottest temperatures ever achieved, temperatures last seen a trillionth of a second after the universe began. Our accelerators are full of engineering superlatives. The beam-containing region of the LHC is a vacuum with lower pressure than what surrounds the International Space Station and is 456 degrees Fahrenheit below zero, colder than the temperature of deepest space. A previous accelerator sitting in the LHC tunnel holds the world record for velocity, accelerating an electron to a speed so fast that if it were to race a photon of light, it would take about 14 minutes for the photon to get a lead of about 10 feet. If that doesn't impress you, remember the photon is the fastest thing in the universe. It goes about 186,000 miles per second. So how do these subatomic particle accelerators work? Well, they use electric fields. Electric fields make charged particles move in the same way that gravity will pull a drop baseball. The force from the electric field will pull a particle and make it move. The speed will continue to increase until the charged particle is moving incredibly fast. A simple particle accelerator can be made by hooking two parallel metal plates to a battery. The charge from the battery moves onto the two metal plates and makes an electric field that pulls the particle along. And that's it. You've got a particle accelerator. The problem is that an accelerator built this way is very weak. Building a modern accelerator like the LHC this way would take over 5 trillion standard D-cell batteries. So scientists use much stronger batteries and put them one after another. An earlier accelerator used this method and was about a mile long and was equivalent to about 30 billion batteries. However, to make an accelerator that is equivalent to 5 trillion batteries would require an accelerator 150 miles long. Scientists needed another way. While electric fields will make a particle go faster, magnetic fields make them move in a circular path. If you put an electric field along the circle, you don't need to use miles of electric fields. You can use a single electric field over and over again. The beams go around the circle, and each time they gain more energy. So very high energy accelerators consist of a short region with accelerating electric fields combined with a long series of magnets that guide the particles in a circle. The strength of the magnets and the radius of the circular path determines the maximum energy of the beam. Once the beam is zooming along, then the real fun begins, the smashing. The reason physicists want to get those particles moving so fast is so they can slam them into one another. These collisions can teach us about the fundamental rules that govern matter, but they'd be impossible without the feat of engineering that is the particle accelerator.
Okay, so that is for the accelerator. Okay, one moment now, guys.
Insignificant though. Insignificant though this bottle of compressed hydrogen gas looks, it marks the beginning of the world's largest and most powerful particle accelerator chain, culminating in CERN's spectacular Large Hadron Collider. Hydrogen atoms from this gas cylinder are fed at a precisely controlled rate into the source chamber of a linear accelerator, CERN's LINAC-2, where their electrons are stripped off to leave hydrogen nuclei. These are protons and have a positive charge, enabling them to be accelerated by an electric field. Their journey to eventually take part in ultra-high energy collisions similar to those following the Big Bang can now begin. This initial acceleration has caused LINAC-2 to be likened to the lumbering first stage of a huge rocket. By the time this packet of protons leaves LINAC-2, it'll be travelling at 1/3 the speed of light. It's about to enter the booster, stage 2 of the rocket if you will. In order to maximise the intensity of the beam, the packet is divided up into 4, one for each of the booster's rings. Straight acceleration is now impractical, and the booster is circular, 157 metres in circumference. In order to accelerate the packets, they are repeatedly circulated, and the electric field is now pulsed, in the same way that you push a child on a swing each time they reach a certain point. Magnets exert a force on the passing protons at right angles to their direction of motion, and so powerful electromagnets are used to bend the beam of protons round the circle. The booster accelerates the protons up to 91.6% of the speed of light and squeezes them closer together. Recombining the packet from the 4 rings, it's then flung on into the proton synchrotron, by analogy stage 3 of our rocket. Let's just follow 2 such proton packets. The proton synchrotron is 628 metres in circumference, and they circulate for 1.2 seconds, reaching over 99.9% of the velocity of light. It's here that the point of transition is reached, a point where the energy added to the protons by the pulsating electric field cannot translate into increased velocity, as they're already approaching the limiting speed of light. Instead, the added energy manifests itself as increasing mass of the protons. In short, the protons can't go faster, so they get heavier. The microscopic kinetic energy of each proton is measured in units called electron volts, and now the energy of each proton has risen to 25 giga-electron volts, or GeV. The protons are now 25 times heavier than they are at rest. The packets of protons are now channeled into stage 4, the superproton synchrotron, a huge ring 7 kilometers in circumference, designed specifically to accept protons at this energy and increase it to 450 GeV. Soon, the packets of protons will be energized sufficiently to be launched into the orbit of the gigantic Large Hadron Collider, or LHC, which lies between the Jura Mountains and the Alps, and straddles both France and Switzerland. Lying deep underground, it has a circumference of 27 kilometers. There are 2 vacuum pipes within the LHC, containing proton beams traveling in opposite directions. Using ultra-sophisticated kickers to synchronize incoming packets with those already circulating, one vacuum pipe has injected into it protons which will circulate clockwise, and the other protons which will circulate anti-clockwise. The counter-rotating beams cross over in the 4 detector caverns, where they can be made to collide. The energy of the collision is double that of the individual opposing protons, and it's the debris from these collisions that is tracked in the detectors. For half an hour, the SPS injects protons. Finally, there are 2,808 packets. During this time, the LHC adds extra energy to each proton, whose velocity is now so near the speed of light that it goes round the 27-kilometer ring over 11,000 times each second, getting a boost of energy at each revolution from the pulsed electric field. Finally, each proton has an energy of 7 tera electron volts, and they're 7,000 times heavier than at rest. The magnetic force needed to keep the beams bending to the ring is so enormous that nearly 12,000 amps must flow through its electromagnets. This is achieved by making the LHC colder than outer space, so that its magnets become superconducting. Now the protons are ready to collide in the detectors. A steering magnet finally brings them onto a collision course. The total energy of two protons colliding in the LHC is 14 tera-electron volts and reproduces similar states to moments after the Big Bang. Particle tracks from these collisions will be analysed by computers connected to the detectors, and it's hoped these tracks will give a new insight into the very birth of our universe, how our universe has evolved, what governs its behaviour today, and where it's going in the future.
Okay, so that is for the particle acceleration. And then the last one is for the Human Genome Project. Okay, so the Human Genome Project, I'm just present this to you guys. Wait, okay. So the Human Genome Project was actually a collaboration with a lot of scientists. So they're actually the main objective of the program was to map the genome sequences of the human body of the humans. Okay, not with the animals, not with other organisms, but with the humans. Okay, so they were actually trying to decipher three things, making the order or sequence of all our bases in our genome's DNA, making maps that show the location of genes for major sections of all our chromosomes. By this, what this means is that in the sequence, malalaman natin na ito yung kung saang part ng DNA sequence makita yung mga characteristics natin. For example, yung long hair, yung straight hair, yung color ng balat natin. And then here, the third major ways is producing what we call linkage maps, through which the inherited traits such as those genetic diseases can be tracked over generations. Okay, so yeah. Let me just check now. Wait now. Okay, ito na pa yung last niya. Okay, so we have the Human Genome Project. Last video niya.
In 1989, a group of scientists was assembled to decode the human genome under the direction of Dr. James Watson.
One of Watson's big motivations here was to try to recruit the best and brightest from many different disciplines, biology, but also physics, chemistry, engineering, because all of those would have to get together if this was going to work.
Many of the biologists, and I love them dearly, of course, were dragged into it kicking or screaming in the beginning because they failed to see the tremendous value that such an enterprise would provide the field.
The talent turned out to be all over the world, so you have to basically make it possible for those bright minds to get engaged where they are. They're not going to all move to join this effort.
Genomics has fundamentally changed the way we do science. It brought the notion of team science and collaboration to biology.
Curious thing about collaboration, it's also intensely competitive. Each person wants to achieve something personal. You know, they want to make their hit, you know, on the problem, but then immediately they want to share it with the other, and the other learns immediately. And so you ratchet each other up.
From the beginning of the Genome Project, there was a fairly strong sense of enthusiasm in the public sector, the private, and academia.
We had lots of support from Republicans, partly because Newt Gingrich was interested in science, and I knew it. There's no partisan difference in everybody wanting to live as long as they can.
I think there's a lesson there. It isn't a big monolithic project. It was a big challenge, but it brought people together. And I think that's what we have to do in the future.
When the Human Genome Project was started, it's important to note the technology of sequencing was not developed yet. So it's, in a sense, a project that was launched with a wing and a prayer.
We couldn't sequence it at that time. The machines were nothing like fast enough. There were no machines even. Sequencing was done by hand.
I thought we might have to do it brute force, and I was quietly prepared to use the old-fashioned technology just because it was so important to get it done.
There are a lot of things, you know, that would make life easier that just hadn't been invented yet.
It'd be a 100-year project like monks working to copy a book at best.
Bit by bit, we got into more and more large-scale sequencing. But the sequencing is enormously important because it provides the possibility of searching by computer.
By the way, guys, let me just cut that short lang, pause lang. James Watson was the one included in the getting the structure of the DNA. Kaya ganun siya ka-enthusiastic in terms of understanding the human genome. Okay? Kasi nagsimulan din silang dalawa ni Crick ang nag-start ng pagde-design nun. So yung nakita natin kanina na matanda, he is the one. Yan. So to si James Watson. Okay? So siya yung gumawa, sila yung nag-design or sila yung nakita ng actual structure ng DNA.
Monks working to copy a book at best.
Bit by bit, we got into more and more large-scale sequencing. But the sequencing is enormously important because it provides the possibility of searching by computer.
When I showed up at Washington University one day with a computer terminal kind of under my arm, people looked at it and said, "What are you going to do with that?" It's a genetics department.
Genomes were supposed to be too complex to be able to reassemble them in the computer.
Without computers, we simply would be dead in the water.
Computers and genomics were made for each other. Genetic information is digital. It's like binary code. It just happens to use 4 digits instead of 2. It is amazingly accurate. And that's what biology gets from digital information.
The Human Genome Project contributed a cultural change about data sharing because the Genome Project was about sharing data almost immediately. And while it seems obvious now, it wasn't obvious then. That required significant effort.
I think I'm quite lucky as a scientist because I grew up always sharing data. The community around me, the genomics community, the worm and fly communities as well. It's just a default that you're going to share everything. You're going to share code, You're going to share everything by publishing, but you're going to share it before publishing. You're going to share half-cooked ideas. And in fact, this is a wonderful thing. It's liberating.
It would have been virtually criminal to try to hoard discoveries that meant the difference in life and death in people.
This is information which we'll be using for centuries. The sooner we get it and everybody has access to it who wants it, the faster we can move in terms of understanding how life works and how disease occurs.
Patients invest a certain degree of fear about genetics. Who's going to find this out? How will it be used against me?
A lot of the ethical and social considerations that we're struggling with today really have historical roots in the early 1900s in the United States, where we had many states that had laws that allowed us to forcibly sterilize people and prevent them from having children based on whether we as a society felt that they were genetically fit.
So at the beginning of the Human Genome Project, we got it right of bringing in the social scientists, the ethicists, the lawyers, and we now have helped to provide a whole generation of scientists that are focusing on the ethical and social issues of genomics.
The sequencing of the human genome was a monumental achievement. Decades of work, thousands of scientists, billions of dollars, and we get this first roadmap for what makes up the human genome. It's an incredibly exciting moment. At the same time, it's just the beginning of what's really a much longer voyage.
And let's again be audacious, but let's not be unrealistic about what's possible.
I think the next 10 years are going to see some exciting developments in genomics, particularly those where we start to use genomic information as part of routine medical care. And that'll be applied to dealing with diseases like cancer, hypertension, diabetes, and Alzheimer's disease.
I dream of the day when every young mother brings a young girl or young boy home from the hospital with a little gene card, and they say, this is the way you should prepare this child's health care. It's exhilarating.
Okay, so that's the lecture for today's session. Any questions so far, guys? Question, guys? Guys, are you still there? Walang question?
Wala po.
Okay.
Wala po.
Okay.
Done po.
Done. Okay, so if you have no more questions, I'll go ahead and end this session. And then I'll have your exam available. Okay? Sige. Bye, class.
Thank you, ma'am. Thank you, ma'am. Bye po.
Thank you po, ma'am.
Thank you po.
Thank you po, ma'am.
Ginawa.
Oo.
Saan basa?
Pag gusto mo may uusap ka naman, hindi, di ba?